concerning aging and rejuvenation processes. Cellular rejuvenation experiment in mice has found to reverse signs of aging. With age comes experience. With experience comes sore backs, tired bones, increasing risks from large number of diseases. Scientists have long been trying to figure out how to stop these aches and pains in our twilight years to make us live longer and healthier lives at the same time. While it's a key, likely a long way off of being ready for humans, a new study investigates the long-term partial reprogramming of cells in mice, and it appears to have produced some very intriguing results. Senior author, Salk Institute developmental biologist Juan Carlos Ispizua Belmonte says we're elated, but that we can use this approach across the lifespan to slow down aging in normal animals. The technique is both safe and effective in mice, he said. The team found that tissues in the kidney of the skin of mice were rejuvenated, quote unquote, and that means that expressions of genes which cause inflammation, cell death, and stress response were lowered in the treated animals. The skin was even able to proliferate more and scar less, the opposite of what usually happens in older age. Also, in addition, the animal's epigenetic clocks, the measures of patterns of DNA methylation levels attributed to aging, seems to be wound backwards. In addition, they said, to tackling age-related diseases, this approach may provide the biomedical community with a new tool to restore tissue and organismal health by improving cell function and resilience in different disease situations such as neurodegenerative diseases. That's just great. That's a long way away yet, as this research has only been conducted on mice thus far, but the treatment appears to be safe and effective in the long term. They said it could, hypothetically speaking, one day help humans stave off some of the worst parts of aging, and the effects can indeed be replicated in people. In the study, the research experiment with 4 well-known proteins that regulate the expression of DNA, OCT4, SOX2, KLF4, and c-MYC, known collectively as Yamanaka factors, after the man who pioneered the technique in stem cells. Although this technique can be used to turn adult cells back into stem cells, the current team had previously shown it can also be used to partially reprogram the cells by reverting them into a more youthful state, but not completely becoming a stem cell again. If the same thing were done to enough cells in the animal's body, this could potentially make the whole organism's body clock seem younger. With this already known, the researchers wanted to look at what would happen to these mice when the Yamanaka factor were applied longer term. In the new research, the factors were used in 3 different ways. The first trial was short. A group was treated with the factors for 1 month when they were 25 months old, equivalent to around 80 years in old humans. The second and third groups had longer-term treatments. One received regular doses from 15 to 22 months, equivalent to 50 to 70 years old in humans, and the other received regular doses from 12 to 22 months, ages 35 to 70 in humans. The mice treated for just 1 month did not show any of the age-reverse qualities, but the 2 larger treatment groups showed signs of rejuvenation without any increased risk of cancer or other health problems. They said overall, this study provides provocative hints, and long-term partial reprogramming holds promise as an intervention that might restore the rejuvenation and rejuvenate the functions of some tissues. This is what researchers Ariana Markle and George Q. Daly from Boston's Children's Hospital, who were not involved in the study, explained. They said it is especially notable that partial reprogramming successfully elicits systemic transcriptonic, metabolomic, and lipodomic changes and alters the epigenetic clock. Moreover, observing these results in a normal aging mouse model provides further evidence that this approach may be beneficial beyond disease states. Although this method is likely many years away from providing a human fountain of youth, it's still an exciting development in anti-aging science, and one that just might help ease the pain and damage of getting old one day. This is published on Nature Aging, is on Science Alert by Jacinda Bowler. Please leave your comments. Thank you for your support. support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.